Question number 22. The figure below represents a triangular flower garden ABC, in which AB is 4 meters, BC is equal to 5 meters, and angle BCA is equals to 30 degrees. Point D lies on AC such that BD is equals to 4 meters and angle BDC is obtuse. We are told to find correct to 2 decimal places. Part A, angle BDC. In this case, we are supposed to apply the sine rule. So I have to state it before we continue with the question. I'll draw a triangle. So if we have a triangle A, B, C, where the capital A, B, C represents these angles, that is angle A, angle B, and angle C, then directly opposite to that angle will have a small letter. So this one will be small letter A to represent the length BC, and then directly opposite capital B we have a small letter B to represent the length of AC. Directly opposite to angle C we will have a small letter C to represent the length AB. So according to the sine rule, if we take small b divided by the sine of capital B, it should be equal to small a divided by sine of capital A, which should also be equal to small c divided by the sine of capital C. So this is the rule we'll be applying for this question. So now we are told to find angle BDC. So this corresponds to the length 5 meters, and we have C, which is given as 30 degrees and corresponds to the length 4 meters. So applying the sine rule, we can say that 4 divided by the sine of 30 degrees is equal to 5 divided by the sine of the angle in question, which is BDC. Then we can cross multiply, and 4 multiplied by sine BDC is equal to 5 multiplied by sine 30 degrees. We divide by 4 and we divide by 4 on the other side. So the sine of BDC is equal to 5 multiplied by sine 30 degrees divided by 4, which is 0.625. Therefore, to obtain the angle BDC, we get the sine inverse of 0.625. So angle BDC will be given by the sine inverse of 0.625, which will be equal to 38.68 degrees. But in the question we are told that BDC is obtuse angle, so the obtuse angle BDC will be 180 minus 38.68. So we have 180 minus 38.68. 0.68 degrees, and this is equal to 141.32 degrees. So this is the size of angle BDC. Part B, we are told to find the length of AD. Again, we are going to apply the sine rule. With the angle BDC given, we can get the value of angle BDA, which will be equal to 180 minus 141.32, and this one will give us 38.68 degrees. Again, we should note that since BD and BA is equal, so it means that this is an isosceles triangle, that is triangle ABD is isosceles, and therefore angle BAD is also 38.68 degrees. So now we can get the value of angle ABD, and angle ABD will be given by 180 degrees, that is the sum of angles in a triangle, minus 38.68 minus 38.68, and this will give us 102.64 degrees. So we have this angle as 102.64 degrees, and we want to calculate the value of AD. Again, we should apply the sine rule. So AD divide by sine 102.64 should be equal to the length, which is given as 4, divided by sine 38.68 degrees. We cross multiply, and we have 4 multiplied by sine of 102.64 should be equal to the length of AD multiplied by the sine of 38.68 degrees. So to get the value of the length AD, we divide by the sine of 38.68 degrees, and we divide this side also by the sine 38.68 degrees. So these will cancel with this, therefore the length of AD will be given by 4 multiplied by the sine of 102.64 degrees divided by the sine of 38.68, which is equal to 6.24. These are meters. Now that we have AD as 6.2 meters, we can go to part C, where we are told to find the length of DC. So the length of DC, from the diagram we have DC, which is part of AC. Again, we will apply the sine rule. So we have to get the value of CBD, that is angle CBD, which will be given by, so this is part C, the angle CBD will be given by 180 degrees minus the angle BDC, which is 141.32 degrees minus the angle BCD, which is 30 degrees, so minus 30 degrees, and this will give us 8.68 degrees. So the angle CBD is equal to 8.68 degrees. Now we can apply the sine rule. So we have DC divided by the sine of 8.68 degrees should be equal to 4 divided by sine of 30 degrees. So we cross multiply this and we'll have DC multiplied by the sine of 30 degrees should be equal to 4 multiplied by the sine of 8.68 degrees. So we divide by sine 30 degrees, we divide by sine 30 degrees, and therefore the value of DC will be equal to 4 multiplied by sine 8.68 divided by sine 30 degrees, which is equal to 1.21 meters, and that is part C of the question. Now we go to the last part of the question, which is part D. We are told to find the area of the flower garden ABC. So the area of ABC, we can use the sine formula to get the area, which is a half AB sine C, where AB is 2 sides of the triangle and C is the angle between the 2 sides. So I take triangle ABC, then I will have the 2 sides of the triangle as AB and BC, then the angle ABC will be our angle C. So we have to get the angle ABC, which is equal to angle ABD plus angle CBD. So we have 102.64 plus 8.68, and this is equal to 111.32 degrees. So the area will be equal to a half multiplied by AB, which is 4 meters, multiplied by BC, which is 5 meters, then we multiply by the sine of C, which is 111.32 degrees. So if we cancel by 2, we have 1, by 2 we have 2. So we have 2 multiplied by 5 multiplied by sine 111.32, which is 0.93156. So if we multiply this, we'll have 9.3156, which can be written as 9.32 meters squared, correct to 2 decimal points.